Good morning or good evening. Today we're going to discuss work. And we know work as things we do throughout the day, such as if you're working in your yard, digging a ditch, or on your house, or putting on a roof, or homework, or pushing a pen across the paper. But in the physics world, for our classes, we need to understand the definition of work. Work is when we use force to move an object. Okay? We use force. Oops. To move an object. Okay? So there must be movement or motion for work to be done. There must be motion of an object for work to be considered done. Okay? So what does it mean to work? All right? Work is when a force acts on an object that moves through a distance. That's the technical definition of work. When a force acts on an object that moves through a distance. So force on an object causing it to move through a distance. Now that may mean, look, pushing your pen across the paper. It moves from the left side of the paper to the right side of the paper. That's moving, that's using a force of your hands, applying a force from your hands to the pen across the paper. Or it could be grabbing a bundle of shingles and carrying them up to the roof. Or pushing a shopping cart through the grocery store. So once again, in order for there to be work, there must be motion. Must be motion. Okay? So if we have to use a force to move an object through a distance, we can calculate work using the formula work equals force times distance. Now you could plug this into your formula triangles like we've done all year. Okay? Whereas you have force measured in newtons, right? Times distance measured in meters. Oops, excuse me. Distance measured in meters. Okay? So work is going to be measured in a Newton meter, which we also call a joule. Okay? So just for the record, we're going to be measuring work in joules. All right? And a joule is equal to a Newton times a meter, or a Newton meter. Okay? So any distance in any formula that we're given, we're going to want to convert to meters. So any distance in any problem we're given, we're going to convert it to meters first, and then we're going to multiply it by the force to calculate joules. Okay? So this again, once again, the symbol for joules is a J. Okay, so remember, if we are given kilometers, if the distance is in kilometers, we have to convert that to meters. And if you just to recall, there are 1,000 meters in a kilometer. So if you have 2 kilometers, you're going to have to multiply that by 1,000 to give you 2,000 meters. Okay? And if you're given centimeters, you have to convert that to meters. All right? So if you're given 100 centimeters, you're going to have to divide that by 100 to get meters. It's 1 meter. Okay. Let's do an example of calculating work. Okay. It says how much work is done if a car moves 250 meters using a force of 25 newtons. Well, let's go back and draw out our formula triangle. We have work Force, distance. Remember, force is in newtons, distance meters, work in joules. Okay? So we don't know what the work is, but they give us the distance it traveled. The car moved 250 meters. Okay? And they gave us the force of 25 newtons. So 25 newtons times 250 meters. Okay, and when you do the math, you plug it in and calculate it out, you find that 6,250 joules of work are done. Okay? Now, it says how much work is done if the car moves 0 meters. Well, remember, what do you have to have for work to be done? You have to have motion. If the car does not move, you have no work done. Now, you can do that just by remembering that that's the rule, or that's the definition of work, or you can plug it into your formula. All right? If you move 0 meters, this number becomes 0. All right? Anything times 0 equals, as you know by now, 0. Okay? So, in summary, work is dependent on two things. Okay? Work depends on the force applied to the object. Okay? And the distance the object moves. Okay? Now, we have to be careful here because the movement of the object, the movement must be in the same direction as the force. All right? So movement of the object must be in the same direction as the force. Okay, so if you're pushing a car and it starts rolling back towards you and you're pushing it north, but it's rolling south, you're not doing any work. It may feel like you are. You may be getting tired, but you're doing no work. So no work is done. No work is done if there is no motion. Or if motion is in the opposite direction of the force applied. Okay? If you have any questions, please feel free to ask. As we come about the room, we'll be there to answer any of your questions as you work on the labs and activities, okay? And we'll see you tomorrow. Hope you enjoy this. Have a good night.